discuss a new topic, very interesting topic, that is alcohols, phenols and ethers. So here, why we have to study? First we should know why we have to study alcohols, phenols and ethers. So generally the people are saying alcohols are only used for the drinking purpose. So not like that. It has many applications, it has many uses, even in the industry, even in the field of medical. So even we have in the field of we are using in laboratory also. So alcohol plays very important role, and even we can use it as a solvent, and phenols we are using as a cleansing agent. Ethers also we are using in cosmetics and also for many other industrial purposes. So to prepare a new compounds, these are all compounds are very important. So here for the point of examination, so this topic is mentioned for 7 marks. So total marks for this topic is 7 marks. So in that we have in part B, so in part B we have for 2 marks question. So in part B we have for 2 marks question, that is question number, the question number is 15. Definitely in the examination for 2 mark it will be there in the part B, so that is question number 15. And we have one more, that is one more question in part D. So in part D the question for 5 marks it is there. So the question number will be, the question number is 33. So total marks for this topic is 2 plus 5 is 7 marks. So 7 marks will be there for your examination. So let us see what is the meaning of alcohol. So first we study for alcohols, then later phenols and ethers. So first, what is alcohol? What is the meaning of alcohol? So alcohols generally, these are the organic compounds, so they are containing OH group as the functional group. So if the OH group is directly linked with the aliphatic hydrocarbon, so aliphatic hydrocarbon, if OH group is present, then that compound is called as the alcohol. So you can take any compound, any aliphatic hydrocarbon, so if it is containing OH group, so then it is called as the alcohol. So the general formula for alcohol is ROH. ROH. So here R represents the alkyl group, or it is alkyl group. R represents alkyl group or alkyl group. There should be this hydroxyl group. This is the main functional group which is present in the alcohol. So for example for alcohol is, you can take CH3OH. Here it is alkyl part, that is methyl alcohol. So this is methyl part, R plus I have written CH3, this is OH part. So we can take CH3 CH2OH. Is it an alcohol? Yes, it is alcohol. Why? The reason is, here there is a presence of OH group. OH group is present in this compound, therefore we call it as it is a alcohol. So we have the classification of alcohol. Classification of alcohols. In your examination they may ask the classification of alcohols. So similar to haloalkanes, here also we have the similar classification. So based on number of OH groups, so based on the hybridization. So based on hybridization and also based on the number of OH groups. So first we classify based on number of OH groups. So now we discuss based on number of OH groups. How many number of OH groups are there? If the OH group is 1, we call it as a monohydric alcohol. If the OH group is 2, then it is a dihydric alcohol. If the OH group is 3, it is called as the trihydric alcohol. If the OH is based on number of OH groups, we have 4 types. So there are 4 types are there. So in that, the first one is monohydric alcohols. Monohydric alcohols. So number 2, dihydric. So it is dihydric alcohols. So number 3 is called as trihydric alcohols. Number 4, it is called polyhydric alcohols. So it is polyhydric alcohols. See, based on the number of OH groups, so here monohydric alcohols means if the organic compound containing only one OH group, we call it as a monohydric alcohol. So here we have, so example CH3OH is there. How many alcohol groups are there? How many OH groups are there here? So only one OH group is present. So if it is only one OH group, then we call it as a monohydric alcohol. So this is called as methyl alcohol. We can take so here CH3, CH2, again CH2OH. Is it a monohydric alcohol? Yes, it is a monohydric alcohol because it contains only one OH group. Therefore, so this is propyl alcohol. Name of that compound is propyl alcohol. So it contains only one OH group. Therefore, it is called as the monohydric alcohol. So next we have second alcohol, that is second type of alcohol, that is dihydric alcohol. So what is dihydric alcohol here? Di means, already you know, di means 2. If the organic compound containing two number of OH groups, then it is called as the dihydric alcohol. So if we are considering a molecule, we are considering a compound, so in that compound, if there are two OH groups, then the related compound is called as the dihydric alcohol. See, for example, I am taking CH2OH, here also CH2OH. So how many number of OH groups are there? So there are 2 OH groups are there. So 2 OH groups means, it is definitely a dihydric alcohol. See, this is generally we call it as glycol. The name of this compound we call it as glycol. So here there are two carbon atoms are there. So ethane 1,2-diol. We are calling it is a ethane 1,2-diol, or generally glycol. Glycol is the name of this compound. So what is dihydric alcohol? So dihydric means it should contain 2 OH groups in the given molecule, so that it indicates the dihydric alcohol. See, then third one, that is trihydric alcohol. The name itself indicates that is trihydric means there should be 3 OH groups. Therefore we call it as a trihydric. See, CH2OH, I am writing CH2OH, next CHOH, next we have CH2OH. See, how many number of OH groups are there? The number of OH groups in the given compound is 3. 1, 2, 3. Therefore, it is a trihydric alcohol. So, the name of this compound, generally we call it as glycerol. The name of the compound is glycerol. Generally we call it as a glycerol. The IPS name for this compound is ethane. Number of carbon is 3. Therefore, it is propane 1,2,3-triol. So propane 1,2,3-triol, or it is a generally glycerol. So this is an example for the trihydric alcohol. Next we have the fourth one, that is called polyhydric alcohol. poly means here it is many. If the given compound containing many number of OH groups, more number of OH groups, so here we call it as a polyhydric alcohol. So poly means more. See here, for example, I am writing CH2OH, next CHOH, 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 and finally CH2OH. Is it a polyalcohol? See, the number of OH groups in this compound is 1, 2, 3, 4, 5, 6. So totally there are 6 number of OH groups are present. So 6 number of OH groups means definitely it is a polyhydric alcohol. Definitely it is a polyhydric alcohol. See, this is, we generally call it as a sorbitol. Sorbitol. Generally it is sorbitol. So the IUPAC name for this compound is, see, the number of carbon atoms 1, 2, 3, 4, 5, 6. 6 means it is a hexane. So in that the hydroxyl groups are 6. Therefore it is hex 1, 2, 3, 4, 5, 6. Dihexane 1, 2, 3, 4, 5, 6. Hexol. Hex. So see here. So it is hex. 1, 2, 1, 2, 3, 4, 5, 6. Hexol. So it is hexa. So hexol. Hexol. Hexane here. It is hexane 1, 2, 3, 4, 5, 6. So what is 1, 2, 3, 4, 5, 6 here? It is a position of OH groups. So position of OH groups 1 to 6 here. Therefore it is 6. So hex. So hex means what here? Hex means 6. 6 OL. So this represents, hexane represents the number of the carbon atoms. Number of the carbon atoms are 6. Next 1, 2, 3, 4, 5, 6 indicates the position of OH groups. Then the number of OH groups is 6, that is hex. Then what is the functional group? That is OH. Therefore it is OL. So this is the example for the polyhydric alcohol. See, so what is the classification here? Just recall. There are, so based on the number of OH groups, there are 4 types. So first one, monohydric alcohol, dihydric alcohol, next trihydric alcohol, fourth one, polyhydric alcohol. So what is monohydric alcohol? If they contain, means the compound containing only one OH group, then it is called as monohydric alcohol. If the compound containing 2 OH group, then it is called as a dihydric alcohol. If the compound containing 3 OH groups, then it is called as the trihydric alcohol. Then if the OH groups are more number of OH groups, then it is called as the polyhydric alcohol. So this is based on number of OH groups we have classified, based on number of OH groups. If we classify based on hybridization, again there are 2 types. So as we have studied in haloalkenes, there also we have studied sp3 hybridized carbon atom, then sp2 hybridized carbon atom. Here also we are studying sp3 and sp2 hybridized carbon atom. So you have to just link it. So as we have studied in haloalkane, it is similar to in alcohols. Don't study like different topics. So you just analyze it. Just what is there in that haloalkane, it is similar. Just compare with yourself. So it will become very easy, very simple. So here, based on hybridization, again we have 2 types, that is sp3 hybridization and sp2 hybridization. Again in sp3 hybridization we have 3 types. First, that is, so saturated aliphatic we have that alcohol, monohydric alcohol. Secondly we have allylic alcohol. So third one we are having, that is benzylic alcohol. So totally there are 3 types here. So first one, that is saturated aliphatic monohydric alcohol. Second one, allylic alcohol. Third one, that is benzylic is about the sp3 hybridized carbon atom which is linked with the hydroxyl group, but in case of sp2 we have only one type, that is vinylic alcohol. Vinylic alcohol. So that we will study in the next class. So first we should know the first classification based on the number of OH groups. Based on the number of OH groups. So we will study the next concept. Here you should remember the classification. Classification is very important. So in this topic we are going to see the number of reactions. See, in the organic chemistry we have many more reactions. So first we have completed haloalkanes and haloarenes. There also we had many reactions. So in this topics also, so in alcohols we are studying just classification. It is there in the phenols also we are having classification. In ethers also we have classification. So after that we have in alcohols we are going to study the nomenclature. Even in phenols also we are going to study the nomenclature, and also in ethers. So next we study the physical properties and chemical properties of alcohols, and it is there for the phenols. Physical properties, chemical properties of the phenols, and also ethers also we are going to study here. So in next we study the preparation of alcohols, and next preparation of phenols, next preparation of ethers. Then some named reactions, some important reactions of the alcohols, phenols and ethers, and also the next we have some applications of alcohols, applications of the phenols, and applications of ethers here. So in this topic we are going to see very important reactions, that is esterification reaction is very important for your examination. Esterification reaction. Next we have Reimer-Tiemann reaction in the phenol. Very important questions, that is Reimer-Tiemann reaction, and Cole's reaction. That is also very important reaction, that is Cole's reaction. And preparation of that phenol by Cumin process, it is also very important. Cumin process. And also for ethers, that is Williamson's ether synthesis is very important. So out of these questions, one will be there for your examination. See, esterification reactions, then we have a Reimer-Tiemann reaction, then Cole's reaction, so Cumin process, next Williamson ether synthesis in the ethers topic. So we have very important